Okay, so I'm going to do this presentation in English. Sometimes I get carried away a little bit with my articulation rate, and so if that should be the case, you're welcome to stop me. Or if there are sort of, I'm trying to stop at the key points, maybe to have to make sure that people get the points, and we can maybe, as you suggested before, translate one or the other things into French. Okay, so this talk is entitled Speaker Recognition Based on Voice Timing, and I'm basically looking at speaker individualities in voice timing, how speakers vary, or how voice timing varies between speakers, and whether listeners can use such information to identify individuals as well. Yeah, and the point of, oops, what's happening here? Hang on. All my keyboard controls don't work anymore. Oh well, no. Okay. So the point of view, or the angle I'm coming from is probably an observation or a phenomenon that we all know pretty well, is that we can characterize or recognize speakers very well based on their voice. Yeah? So characterize means if you receive a phone call, for example, from a strange person you have never seen before, typically you know immediately, oh, this is a male or a female. You know, you can roughly sort of judge the age of that person, maybe you can judge the heritage, where does the person come from, you can judge the mood of that person, you can judge the state of health of that person, and so on and so forth. We could probably give an endless list of all sorts of characterizations here. And if we are familiarized with some of the key or more static characterizations of a speaker, then we can also recognize speakers very well based on their voice. We all know that if we get a phone call, I mean, nowadays the name always appears on the display, but until a few years ago still it was you receive a phone call and you don't know the caller. You pick up the phone, and usually the phoner says just, so the person phoning says like, hi, it's me, or something, and you immediately recognize the person based on his or her voice. So basically that means the speech signal contains numerous speaker idiosyncratic or speaker individual information. Yeah? So it's not only linguistic information or that we're typically interested in there. So why would we be interested in things like that? Why do we study speaker identification? Well, there is a clear sort of linguistic, phonetic, phonological motivation maybe that arose over the past 10, 20 years. So while it was earlier on, people always believed that there is a clear separation between linguistic information and so-called indexical information. That means sort of information concerning the message of the signal and information concerning the speaker, while people always made a very clear separation. If you think of sort of Chomsky's transformational, generative transformational grammar, you see, while there is a ideal speaker-hearer situation where you have competence and you have performance very well separated from each other. Yeah? And people over the past 15, 20 years realized more and more, well, there is much more of an interaction between the two, actually. Yeah? So, and we found in experimental work, I mean, we, like in general, like speech scientists, found in experimental work that it's much easier to, or speech is much more intelligible, and it's much easier to process linguistic information once we know the speaker, once we are habituated with the speaker, or the other way around. It is much easier to identify a speaker once we understand the linguistic message of that of the signal as well. Yeah. So the two are not basically the two are not very well separable as we always thought maybe. So it's very interesting to study speaker individual behavior from a linguistic point of view. And then there are clear practical applications of this. And these practical applications are in areas like forensic phonetics, where we use speaker individual information to identify perpetrator, for example, based on his or her voice, or an automatic speaker recognition. You all know these systems from your smartphones where we speak to and the system can recognize us or the messages we are producing. So where it would lead to. Why are we interested? I sort of named this slide why study speech rhythm, because that's basically the link I'm trying to make here a bit later as well, with that this voice timing that we are looking at is very closely related to our perception of speech rhythm. And why are we interested in speech rhythm in speaker individuality? Well, there has been an awful lot of work, and a lot of it has been carried out in France by a figure, or by a person who I understand is very prominent in France as well, Franck Ramu, working in Paris. And he found basically that listeners can distinguish between different languages based on timing characteristics, not of voice, but of consonantal and vocalic intervals, but so more segmental aspects here. But it is very, very related to the voiced signal, I would say. And we also see that in some of the data I'm going to show later. So they said, well, basically, so why is that important? Because, they found that adults and even infants, so newborns, can distinguish between different languages on the basis of these rhythmic or vocal timing characteristics, vocalic timing characteristics. And why is that important? Well, because probably these timing characteristics, they lie at the bottom of all speech acquisition. So when we are born, we use this timing characteristics of a language, and then we put all the other characteristics on top. And they also found that, well, once a child then, or once a newborn is born into a bilingual environment, the first thing you can do is basically segregate different languages that differ in their timing characteristics, and then sort of focus on one and acquire the one and the other. So if that is true for different languages, then my argument would be, well, maybe it would even be more interesting if we find these differences between individuals within the language, then the baby or an infant could also use that information to segregate individuals instead of languages, and that is probably a task that is much more important for an infant. The first thing you have to do is to segregate between your mother and other women, or your father and other men, but and this accounts probably for all babies in the world, and not all because not all babies get born into bilingual environments, so they're not all confronted with the task to segregate between different languages. Okay, when we look at traditional way or the way that speaker identity has been studied or looked at in the past, is that people made a clear relationship between the anatomy of the vocal tract and the signal frequency envelope. So basically frequency domain characteristics of the signal. Are you familiar with these concepts actually mostly? Okay, right. So I don't need to talk about this much more, I guess. So there's this source filter model where we see like, okay, so the size of the larynx basically determines our fundamental frequency, so whether a speaker has a low or a high voice, and then we have the vocal tract resonances that determine our formant frequencies, and basically if we hear, or if the formant frequencies in total, like their average is sort of higher or lower, we can we automatically as a listener make an inference to the anatomical characteristics of the speaker, whether they're larger or smaller vocal tract characteristics, and so we can use that for the speaker segregation. And this stuff has been used a lot, or a lot of the automatic algorithms rely on these type of characteristics or these type of features, and a lot of the forensic work as well in the speaker identification relies on exactly these type of characteristics. What has been neglected so far, pretty much, or this sentence is supposed to come later actually in the end, what has been neglected so far is sort of temporal or rhythmic aspects of the production, and that is quite surprising. And why is that surprising? Basically, when we look at other domains of research that are sort of concerned about human body movements, we find that studies on human gait, for example, so the way people walk, have shown that, well, walkers, they have a highly individual way of moving their legs and arms and sort of, yeah, their whole body. And if you sort of mark different points along the body and calculate the dimensions and the movements between these dimensions and calculate some mathematical algorithms over this, we can identify individual walkers pretty well based on these movements alone. Yeah? So if we look at speech, basically, speech articulation in essence is body movement as well. Yeah? So like people move their legs and their arms and their whole body when they walk. We as speakers move our jaw, our velum, our lips, and our tongue is basically around, what do we reckon, maybe something like 200 muscles involved in speech production, so they all need to be coordinated and they all are involved in pretty complex movements. You all know about these things. So, now it would be interesting to say, well, if to make a direct analogy between this, what we could do is like mark points, as these people for the gait research did. We could mark points along the jaw, the tongue, and the velum maybe, and sort of calculate different movement behavior, and then use the same algorithms that they did and try them out. I don't know if there's anybody who did that already. It might well be actually, but we wanted to go one step further because we had like initially, as I said, the point of view I'm coming from is a little bit forensically motivated, and so we wanted to go one step further immediately and say like, well, this articulation or this individual articulation behavior, that should leave traces in the acoustic signal, because in particular when you look at a forensic application or so, you would think like, well, you never have data about these articulatory movements from a perpetrator, for example, but you do have recordings of the acoustic signal. Yeah, so we were basically in the first step we were interested in the acoustic signal, although the movement behavior is equally in particular from a theoretical point of view, I think is equally interested. So it should leave traces in the acoustic signal, and then our voice timing behavior, so the way we use voice is everything that Adrian basically explained in the first talk. When we turn on and turn off voice, yeah, that should to some degree be influenced by this articulatory behavior. So when we need some time to move our articulators in a certain positions before we turn the voice on and turn it off again. So all this should interact in some ways. Right now, sort of an obvious question that might come up at this point is that Adrian argued before, and he said, well, if we look at the voice timing across between different languages or between the individuals, we find that they all want to get to this 50-50 percent usage of voice timing here, and I will show some results where I show now, oh well, but actually this the proportional times people spend on their voicing might vary between languages even, or between individuals. But I just want to say, like from the beginning, I'm looking at voice from a slightly different point of view, that I only look at filled speech, as opposed to what Adrian did, like the entire speech signal with all the interruptions and pauses and breathing activity in between. So I'm only looking at filled speech. That means all the segmental content, basically, of only when we have segmental content in speech, and it's only linguistically relevant content so far, so not at hesitations or filled or unfilled pauses or things like that. You know? Okay, and so the two research questions I'm asking here is, first of all, are speakers individual in their voice timing? So what differences do we, or which differences do we find? And the second question is, can listeners recognize speakers based on such voice timing characteristics? I'm going to show you results from a perceptual study that we carried out recently in Zurich. And then I sort of just theoretically or hypothetically, this second question, if we can answer that with yes, so listeners, they can do it, then we could say like, oh, well, that explains our auditory, or is part of an explanation of our auditory speaker identification ability, so just general speaker identification ability of human listeners. And if we can't do that, then it may be that this is just some sort, then the voice timing is some sort of byproduct of the articulation process. And if we can't, if it's not perceptually salient, so if we can't identify individuals based on it, that would mean we have little control over it, probably to manipulate it, and that would mean it's probably useful for forensic speaker comparison, forensic applications, in which, or where we are interested in characteristics, in voice characteristics or speech characteristics that people have very, very little control over, so that they can't use it to disguise their voice, probably. Yeah. So if we look at fundamental frequency or so, speakers can obviously just disguise it very easily by talking with a higher or lower fundamental frequency. But then if there are voice timing characteristics that are produced by these movement articulations, if listeners can't process them, that would mean they would be a good candidate for this. Okay, so the question one, are speakers individual in their voice timing characteristics? First of all, to give you some background on the voice timing characteristics, there was some work I did together with Adrian on this. We looked at voice timing in filled speech. We looked at sort of vocalic intervals and voiced intervals. And there is a number of different, or if you look at vocalic, consonantal, or voiced, unvoiced, temporal characteristics, there is a number of different ways you can calculate that. So this space is rather multidimensional, I would call it, and but probably two dimensions that have been used a lot in the past and that are also somehow that are somehow plausible and make sense to look at is a variability measure of voiced intervals. So that means like we're looking at the variability of the durations of the voiced intervals, but that tells us, okay, if we have a high variability, we should perceive a highly irregular signal. If we have a low variability, we should perceive a rather regular signal. Yeah? So you have something like as opposed to yeah. So that would be the like sort of, and then people also looked at the proportion over which speech is vocalic or over which speech is voiced, yeah? And this proportion basically. I would ask you to just believe it for the moment that that it makes sense to look at it. I would have to give a sort of wider explanation how to arrive at that point, but it is related basically to language-specific differences in their phonotactic or phonological structure. So if we have basically if we have languages that have more or less complex consonant clusters, then we would expect them to have sort of higher, more or less longer durations of voiced and voiceless, or vocalic and consonantal stretches and intervals they're using, and that leads to a variability in the overall amount of time, the overall amount of duration that the voicing is set in during speech. And so basically, in a nutshell, to cut that short, that is one of the measures that has been used a lot in this time of rhythmic or voice studies so far. And what you see here is two measures like percent V, that's percent vocalic, percentage over which speech is vocalic, and percent VO, the percentage over which speech is voiced. These are these proportional, these ratio measures between voiced, voiceless, vocalic, consonantal time. And here you have everything that is sort of with delta and delta, consonantal, voiced, unvoiced. Here we have PVI, pairwise variability in it. These have all to do with the variability of these voiced or unvoiced measures. Yeah? So in the first, or like in the beginning, Adrian and I, we looked at differences between languages that have been classified as belonging to different rhythmic classes. And so here we have data that was originally used by Franck Ramu in these studies where they showed that there are these between language differences. And we wanted to see, well, apart from the vocalic and consonantal differences that they found and the timing differences in consonantal and vocalic intervals, are there differences in the voiced and voiceless intervals? And we found when you compare, in particular, these two graphs, we have what 3 types of languages we can say that have been classified as being similar in terms of their rhythm. So that would be sort of the stress-timed languages, syllable-timed languages, and mora-timed languages. And we see stress-timed languages here would be, I think they had in there English, Polish, and Dutch. Yeah, and syllable-timed language here would be French, Spanish, Catalan, and was Portuguese in there? Sorry, I kind of should have really looked that up. But it was definitely French, Catalan, and Spanish in there. Oh, Italian they had still in there, these 4, yeah, Italian. And then as a mora-timed language, Japanese. Yeah? And when we compare the 2 graphs, we see, well, the differences aren't that great. There are significant differences between the languages, whereas Japanese, or these mora-timed languages, always having the highest percent V, syllable-timed language somewhere in the middle, and stress-timed language is the lowest percent V, and if we look at voice timing, we get a very similar picture. Yeah, so we see, okay, so these 2 types of measure, or these 2 characteristics are very, very closely related. What we would also expect, of course, because there is because obviously all the vowels are voiced and the consonants can be voiced or unvoiced, so you might get some variability, but it's not so large that it shows us a completely different picture here. Yeah? And we carried that, like measurements like this, we carried out in a lot of different databases and looked at a lot of different languages, and always got the result confirmed that we found, okay, so languages differ in terms of their in terms of their voice timing or vocalic timing structures, and people have made that argument a lot that it has to do with stress time and syllable timing. That is very much disputed upon. Obviously, you know this rhythm, all this rhythm class discussion that has a lot of baggage, and whether that is stress time, syllable time language, I leave that up to decide for yourself. But what we definitely find, and that's what a lot of people have confirmed, is that individual languages, they differ in this type of structures. Yeah? Whether that is a categorical continuous difference or something, as I said, that is highly disputed upon. And but it makes sense to talk of languages in terms of this type of variability, and it's also, as Franck Ramu and colleagues have shown, where there are differences between or human listeners can use these types of characteristics to distinguish between the languages. So we looked at a number of other databases here. I don't want to look too much into detail at these results, but we looked at voice timing, for example, on a database of Swiss German speakers that we recorded under different speaking styles to see, okay, how much does within speaker variability influence this voice timing, or is there when we have within speaker variability, does that sort of blow up the voice timing differences or other sort of rhythmic differences between speakers, and we found even across different speaking styles, we had 16 speakers here, and even across different speaking styles, speakers were maintaining their voice timing characteristics pretty well. And we also found that, surprisingly, in some other data for bilinguals, when we look at bilinguals speaking in 2 different languages, so our bilinguals, they spoke German and Italian. We found that, we only had 5 speakers here, but we found when we looked at the percentage over which speech is voiced, that in Italian this percentage is always higher than in German. So the darker graphs is the Italian speakers, the white ones is the German, the German performance, and they're all the same speakers, of course, speaking German and and Italian. And so we always got this language effect in there, but we also saw that the speakers with a higher %V, they have a higher %V in both languages. Yeah, so they not only have that in Italian or German, there's no interaction between these two. There was one speaker that fell a little bit out who had this sort of higher percentage V in Italian, but then went down with the German. And but basically, I mean, this was more like pilot data we looked at, but we had it confirmed, and we saw even when we look at speakers across different languages, we see that they maintain some of these characteristics. This is actually something. This is from data from the TIMID database. You might know. We just looked at okay, whether to what degree such voice timing can be influenced by dialectal variability. Then, are you familiar with this TIMID database? Texas Instrument MIT database for speaker identification. Yeah, is a prominent database sort of that people in speaker identification research use a lot, apply a lot to test their methods or to test their devices. And so it's a database on American English that contains 8 different varieties of American English, and in there we just saw like, okay, across the different varieties of American Englishes, I can't recall which one there was, sort of New York, Southern, Northern, Central, or whatever. Across these different varieties that they recorded, we did not find any differences in voice timing, but when we looked within the varieties, we always had a very drastic difference between the individuals here. Yeah, so that occurred. Okay, and then we compared this with a number of other timing measures in our group in Zurich, and we compared a number of other timing measures. So we didn't only look at voice timing, but also sort of at envelope peak timing in the speech signal, at consonantal vocalic timing and everything, and we fed all these parameters in a nominal logistic regression model to see, okay, which one explains most the variability between speakers, and then these two parameters, percent voiced and percent voiced and percent vocalic, they came out very, very prominently, yes, compared to the others. So probably there is something in this percentage, or like, yeah, so the amount of time, the proportional time of which speech is voiced, that is very strong between, or is a strong difference between speakers. Okay, now to question 2. Can listeners actually recognize speakers on such voice timing differences that I showed so far? And maybe I should put it all onto it. Yeah. So so the first thing we did recently was a speaker identification or speaker recognition experiment using low-pass filtered speech. So what we did, basically, low-pass filtered speech, we filtered the speech below 350 hertz. Are you familiar with these procedures? That what it sounds like? Yeah. Okay. So you get this wobble wom. So basically, what you leave in is the fundamental frequency characteristics of speech. Then, so we low passed filter speech below 350 hertz, and when you do that, what you leave is the average difference between speakers in their F0. So speakers with a higher or lower F0. These were all male speakers, so they were all below 350 hertz. Yeah? So we leave the average difference in, whether someone has a higher or lower voice that listeners can use. Obviously, we leave intonation differences in, so the melody that speakers produce with their voice, and we leave duration differences in with these voices. Yeah? Then we said, okay, from there on, we want to strip all this information down over 3 conditions. First, check out the average differences. We normalized the F0, so we created an F0 that for each speaker that has the same average and the same standard deviation. Yeah, so so speakers still have the melody, listeners still have the melody of the speakers, but they don't have the, they can't use the average difference anymore. Yeah? And then we stripped down of the intonation as well, and we said, okay, so we set the fundamental frequency to a monotone, yeah, so that we only have the durational information of the F0 then left over. So, yeah, certainly, yes, I was going to do that. I actually, in these slides, I forgot to put the original in, and I have I just looked up the an example with the original and the filtered conditions, and I played to you, but I didn't have enough time before to fit it in the slides. So here I give you a sentence that was in the experiment by a speaker. It's in Swiss German. You won't understand very much, I think, but.
Von dort aus laufe ich meistens an die Uni rauf.
Yeah, and then here is the band pass. I call it low pass filtered, but in essence it was a band pass filter because we also filtered the lower 50 hertz because we didn't want any sort of infrasound interfering with anything in the stimuli. So it's that's the low pass condition basically. Yeah. So here, if you hear the original again.
Von dort aus laufe ich meistens an die Uni rauf.
Yeah, and once speakers have heard the sentence before, then it's actually intelligible for them as well. But if you have not heard the sentence, you might know that effect. Then this speech is 100% unintelligible. They can't understand a single word in here. Yeah. So then we have the normalized condition. I play them in contrast to the band pass, where you hear, okay, so the average has been adjusted a bit, so that listeners can't use the average again anymore. So this is the band pass. That's the normalized. Yeah, so it's slightly higher, and then obviously the change depends very much on the speaker and the sentence. Yeah, so how much this changed. For some it was more drastically, for others it was less drastically. And then we have the flat condition where we just created a flat F0, and that sounds like. Yeah. Okay. Right. Okay, so what did we do with that? We fed that in an experiment. We created an interface with Urs, Hans, and Ed, and sort of we trained listeners or we had 3 steps in the experiment. First a familiarization step, then a training step, and then a test round. And in the familiarization, basically, listeners just saw the picture of one of them and heard the voice of a speaker along to it, so that they learned to relate the voice to a particular picture in here. Yeah. The faces had nothing to do with the original appearance of the speakers, and we just tried to create or try to make sure that because listeners apparently, like the psychological literature, they tell us the methodology tells us that listeners, they pay attention to different cues, and some they look more at color differences, some look more at shape differences, some look more at the name differences. So we wanted to make sure that any of our listeners is able to learn these pictures. So we had different colors, different head shapes, different hairstyles, different names, and everything in there. So that they could just use any cue to relate it to these voices. They just need to relate the voices with something in that picture, basically, that their memory allows them to do well. So we had the familiarization. We played them 5 sentences per speaker, so just that they get to know the speakers. Then we had a training set with clear speech, and in the training set we played them 20 sentences. We played them 20 sentences per speaker, and we trained them basically with that set until they reached something that was close to 100%, between 95 and 100%. And that step is very, very easily reached. For 3 speakers, 3 voices, the voices were rather distinct. That step is actually, it's very quickly reached. Yeah? So the listeners can do that very well. And then we had a test set in which we played them 130 study stimuli of this degraded, of one of the degraded conditions. It was a between listener design. We had, so that doesn't sum up, actually, this is a, I had to update that slide and I forgot to change some of the information. So we had 60 listeners, so it was 20 listeners per condition in here, so not 12. And so we had a between listener design because we thought, like, if we did a within listener design and they all hear to the, they all listen to the same conditions because they are quite equal. If they have the flat conditions, probably yeah, you might detect some behavior. They think, oh, I can't do that anyway, and then they don't listen properly anymore. But if they only get the flat condition, obviously they have to develop some sort of strategy to solve that. Yeah. So we had 20 listeners per group, and what we did was the training and the test set with the stimuli was also we had different sentences, right? So we had basically 20 training sentences, 45 test sentences in there, so 65 sentences per speaker in total. And before each listen, so all the sentences were different to begin with. Yeah, none of the sentences were equal between the speakers and within the speakers. So no sentence occurred twice in the entire experiment. And before each listener, we randomly split the test set apart into the 20 test sentences and 20 training sentences and 45 test sentences. Yeah, so none of the listeners got the same training and test set, basically. Yeah? So the only thing they could do in that experiment here is really sort of get an abstract picture of the timing of these sentences for each speaker, and then use that abstract timing that they learned later on in the experiment. Yeah. Okay, what did we find? Here are the results for this. That's the accuracy plotted as a function of the 3 different conditions we have. Here is the full intonation, so the low-pass filtered, where they have the average, the variability, and the timing differences. The reduced intonation is the second one, where they only have the melody, basically, and the timing differences, and that we call the rhythm only. So that's only the timing differences. Here you got the chance line at 0.33, and we found for all 3 conditions, and that was the important effect that we got. We found for all 3 conditions that they were significantly above chance. Yeah? So that means even in the 3rd condition, listeners, they could, to some degree, at least, you see the magnitude of that effect is much lower than it is, of course, for the full intonation condition. But we saw, okay, for all in all conditions, listeners could perform the task to a certain, at least to a significant degree. Yeah. We'd also found significant differences between the conditions. You can see, okay, as the signal conditions, signal degradation is stronger, the performance goes down. Yeah, you would of course expect that. It's difficult a little bit to compare this effect between the conditions, also because obviously when you manipulate voice and create a flat F0, you introduce many more artifacts in there than when you just low pass filter it. Of course, then you still have a natural signal that's just low pass filter, and here we don't. So it's difficult to say, in other words, to what degree that effect depends on the degradation artifacts, or to what degree it depends on listeners' loss of information in here. Yeah? But so the important message in here is, I think is, if we do strip it down that way and we leave listeners with just durational information in voice, there is still something there that they can use to distinguish between the speakers, even though they were familiarized with the normal voices, the voices, high quality signals of the voices of the speakers. Okay, so as a conclusion, we can say, well, there is strong reason to believe that languages and speakers then vary in their voice timing characteristics. And we found evidence that adult listeners can make use of these voice timing characteristics for recognizing speakers. And then if we go back to this slide that I introduced in the beginning, this infant work by Franck Ramu, and it's given this previous work on speech rhythm, it seems conceivable that infants might be able to use speaker-specific information in voice timing also to distinguish between adult speakers like mother and other women and father and other men, and we're currently trying to test that in an infant experiment in Colchester soon. Okay, yeah, that's it. Thanks very much for